Hello guys, Model 1 paper for 2025, 25-26. To solve the following linear programming problem. So minimize z is equal to 10x plus 8y. So equation number 1, subject to constraints 4x plus y greater than or equal to 40 and 2x plus 3y greater than or equal to 60 and x comma y greater than or equal to 6. Let me start from 2. From 2, 4x plus y greater than or equal to 40 becomes 4x plus y is equal to 40. Similarly, 2x plus 3y greater than or equal to 60 becomes 2x plus 3y is equal to 60. Now step number 2. Okay. Now 4x plus y is equal to 40. So y is equal to 0. 4x plus 0 is equal to 40. So 4x is equal to 40. So x is equal to 40 by 4, that is 10. Similarly, x is equal to 0. 0 plus y is equal to 40. Therefore, y is equal to 40. So x comma y, so 10 comma 40. Similarly, 2x plus 3y is equal to 60. But y is equal to 0. 2x plus 0 is equal to 60. So 2x is equal to 60. X is equal to 60 by 2. So 30. Similarly, 0 plus 3y is equal to 60. So 3y is equal to 60. So y is equal to 60 by 3, so 20. So 30 comma, so 30 comma 20. Okay, we have a 2 point. One is 10 comma 40, and the second one is 30 comma 20. Okay, x-axis highest is 10, 30. Y-axis highest is 20. Okay. So now the y-axis, the x-axis. So 30 is the highest one. So x-axis 30, 5, 10, 15, 20, 25, 30. The second highest is y-axis is 40 highest, x-axis 30 highest, 5, 10, 15, 20, 25, 30, 35, 40. Okay, the first point is 10 comma 30. 10, so 30. 10 is x-axis, so 10 comma 40. Sorry for the so 10 comma 40. So 10 comma 1. Fine. So that is greater than or equal to. It means outside the hot string. Outside the horizon. Next 30 comma 20. 30 and 20. So 30 comma 20. Okay, 30 comma 20. Now that is also so greater than or equal to so outside the hot string. Note that this is minimization. So this is unbounded solution because we didn't get any end point of the feasible solution, isn't it? So this is unbounded solution, but we are going to identify three corner point. Let me see. So this is the feasible solution, starting area of feasible solution. This is the starting area of feasible solution. Okay, so we have a three corner point. So one is called A, minimization sum, unbounded. You have to do the corner point step and optimal solution. Okay, A point, then B point, then C point. Correct? Fine. So let me see the corner point. So corner point, and the first one, so minimize Z is equal to 10x plus 8y. As I repeated, maximization, this type of sum come. So this is unbounded, you have to stop here. But minimization problem, there is an unbounded solution. We should take the corner point, starting position of corner point, this area. Okay. So A corner point, 0, 40. A corner point, 0, 40. So 0, 40. So B corner point, we have to find C corner point, 30, 0. Let's see what is the B corner point. Okay, B corner point is 4 is equal to 1 is equal to 40. In second, 2 is equal to 2 is equal to 3 is equal to 60. Okay, so I got x-axis is 6, y-axis is 16 I got. So 6, 6. So A corner point is 0, 0. Minimize Z is equal to 10 into 0, 0 plus 8 into 0, 0, 40. Sorry. So 0, 40. So this is 40. The answer is 8 into 40. So 8 into 40. So 320. So 320. Similarly, B corner point 6, 16. So minimize Z is equal to 10 into 6 plus 8 into 16. Okay. 10 open bracket 6 plus 8 into 16. You got 188. Okay. C corner point 30, 0. So minimize Z is equal to 10 into 30 plus 8 into 0 is equal to 300. Okay, that is the final answer. They asked minimization. The minimization is 188. Yes, they asked minimize sum. So we should identify minimum problem, minimum answer in these 320, 188, 300. Minimum is 188. The final answer, minimize Z is equal to, minimize Z is equal to 188 when x is equal to 6, y is equal to 60. So we'll go second question. Model 2 paper. Yes, this is Model 2, 25-26, PU board release, Model 2 paper. Ready with? Solve LPP by graphically. This is also minimization. Minimize that is equal to 10x plus 15y, subject to constraints. So 4x plus 3y greater than or equal to 24, and 4x plus 5y lesser than or equal to 40, and x comma y greater than or equal to 0. So 1, 2, 3. So from 2, 4x plus 3y greater than or equal to 24 becomes 4x plus 3y is equal to 24. Similarly, 4x plus 5y lesser than or equal to 40 becomes 4x plus 5y is equal to 40. So now put y is equal to 0, x equal to 0, x comma y point. Okay. The first one, 4x plus 3y is equal to 24. So y is equal to 0. 4x plus 3 into 0 is equal to 24. So 4x is equal to 24. X is equal to 24 by 4. So x is equal to 6. So x equal to 0. So 4 into 0 plus 3y is equal to 24. So 3y is equal to 24. Y is equal to 24 by 3. So 8. So x comma y point 6 comma 8. Similarly, 4x plus 5y is equal to 40. Y is equal to 0. 4x plus 0 is equal to 40. Therefore, 4x is equal to 40. So x is equal to 40 by 4. That is equal to 10. Similarly, x equal to 0. So 0 plus 5y is equal to 40. 5y is equal to 40. So y is equal to 40 divided by 5. So that is 8. By 8 the 40. So finally, so 10 comma 8 we got. So we have a 2-point first equation 6 comma 8. Second equation 10 comma 8. So this is the second step to draw the graph. So we have a axis point, equation number 1, equation number 2. Equation 1, 6 comma 8. Equation number 2, 10 comma 8. Now draw x and y axis. Okay. So x-axis is highest 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is y. The y-axis is 8 highest. So 1, 2, 3, 4, 5, 6, 7, 8. The first point 6 comma 8. 6 comma 8. Okay, so that should be greater than or equal to, say, outside the function. So this is outside the function. Okay, next point is 10 comma 8. This is 10. This is 8. So 10 comma 8. So let me mark 10 comma 8. Okay. So that is lesser than or equal to. So means inside the function. Lesser than or equal to means inside the function. Okay, this way. So inside the function. Look at that. So this area, both the colors are coincide. So this is called feasible. This is called feasible region. Let me check A point. So 0 comma 8. So B point, so 10 comma 0. And C point, 6 comma 0. Is now corner point. So minimize Z is equal to 10x plus 15y. The first one, A corner point, 0 comma 8. So minimize Z is equal to 10 into 0 plus 15 into 8. 15 into 8, so 40. Answer is 40. So B corner point 10 comma 0. So minimized Z is equal to 10 open bracket 10 plus 5 open bracket 0. So 100. So C corner point 6 comma 0. So minimize Z is equal to 10 into 6 plus, so 5 into, not 5, 15, sorry, not 5, 15. So 15 into 8, so 120, sorry, the first one answer is 120. The first answer is 120. Then 15 into 0, the answer is 60. So it asks minimization, which is the minimum answer out of 120, 160. So the answer is 60, the least one. The least one. So final answer, minimize Z is equal to, minimize Z is equal to 60 when X is equal to 0, Y is equal to 6. Sorry. So X is equal to, so X is equal to 6, Y is equal to 0. This is the minimum. So this is the second problem. And we'll move on to model 3. Yes. Model 3 paper. So question number 35. Question number 35. So this is the problem. So maximize Z is equal to 2x plus 3y subject to constraints x plus y greater than or equal to 350 and 2x plus y lesser than or equal to 600 x comma y greater than or equal to 0. This is 1 and this is 2. and this is 3. So let me start from 2. From 2, x plus y greater than or equal to 350 becomes x plus y is equal to 350. 2x plus y lesser than or equal to 600 becomes, so 2x plus y is equal to 600. Put y is equal to 0, put x equal to 0. Okay, the first one, x plus y is equal to 350. So y is equal to 0. So x plus 0 is equal to 350. Finally, x is equal to 350. So x is equal to 0. So 0 plus y is equal to 350. So y is equal to 350. So 350 comma 350. 350 comma 350. Second one, 2x plus y is equal to 600. But y is equal to 0. 2x plus 0 is equal to 600. Therefore, 2x is equal to 600. So x is equal to 600 by 2. So x is equal to 300. Similarly, put y 0 I put. Now put x 0. So 0 plus y is equal to 600. Therefore, y is equal to 600. Finally, 300 comma 600. Okay. The second one, 300 comma 600. So this is step number 2, draw the graph. Now take scale and pencil. So using graph sheet. Okay. Now y x-axis. Highest is 350. X-axis will take 50, 50. 50, 100, 150, 200, 250, 300, 250. So y-axis highest is 600. So 100, 200, 300, so 400, 500, so 600. Okay, the first point, 350, comma 350. So 350, comma 350. Okay. So 350, comma 350. So that is greater than or equal to. So that is first line greater than or equal to outside the hall. Outside the hall. Second point, 300, comma 600. 300, comma 600. So 300, comma 600. Okay, that is lesser than or equal to x. That is lesser than or equal to inside the hall. That's it. Yes. Look at this area, both the colors are coincide. Okay, only this area. Yeah, this is the three corner point we get A, then B, here is the C. Okay, A corner point 0, 350. The B corner point 0, 600. So C point we want to check. C point 1 is equal to 1 is equal to 350. Then 2 is equal to 1 is equal to 600. So X is 250. So Y is 100. So I got X is 250, Y is 300. Fine. This is X point. A point is 0, 350. Fine. Now corner point. So minimize Z is equal to 2x plus 3y. Okay. So A corner point 0, 350. So maximize this, sorry, maximize Z. So maximize Z is equal to 3 into 350. 3 into 350, 1050. So B corner point 0, 600. So maximize that is equal to 3 into 600. 1800. 1800. C corner point 250, 100. So maximize that is equal to 2 into 250 plus 3 into 100. So 800. So 2 into 250 plus 3 into 100. Okay, finally, so they are maximized out of these three, which is the maximized 2800. Look at that. 1800 is the highest one. So we are able to write the conclusion. So maximize Z is equal to 600. So when X is equal to 0, Y is equal to maximize is 1800, sorry. Maximize is 1800. And X equal to 0, Y is equal to 600. Okay. Plus okay, fine. The final answer is maximize Z is equal to 1800, and X equal to 0, and Y is equal to 600.